In this video, what we're going to do is get the Find and FindNode methods up and running in the TransformNode class. Now, the FindNode method is a little bit more sophisticated than most of the other methods inside the TransformNode class. It's kind of similar to the showTree method, where the showTree method took advantage of recursion because it needed the ability to walk through a hierarchy. Well, when finding a node, we're going to need that same ability. We need to walk through a hierarchy. Now, we're going to do one thing that is a little bit different than the recursion that we saw back over here, but I can demonstrate it to you with the showTree whiteboard example that we had earlier. And this will just save some time so we won't have to retrace out something that's going to end up looking very similar to what we have here. Now, going into FindNode, one of the things that we would like to be able to do is get the result of a particular node if the node is found. So if the node we're looking for, we find it, we would like to get that returned back as a result. Well, with using returns, when you're dealing with recursion, that gets a little interesting. As you can see with the example we set up here, where you see all of these removed, what if we had to take returned information and then work with it back with who we just returned back to, and that had to keep bouncing all over the place? That could become a bit messy and a bit confusing very quickly. So instead, what we're going to do is we're going to use something else that was introduced to you guys a little while back, and that's passing a parameter by reference, okay, or passing a variable by reference. So that's what we're going to do here. So the example I'd like to do is, let's just say that we modified our showTree, where showTree still took in an int, just make it a little bit smaller, an int depth. All right, so it's got its int depth, and then also it took in a reference. Let's see if I can get myself just a little bit more room. So a reference node, and then we just give the node some sort of name like result. Of course, pretend all of this is on the same line, of course. Okay? So reference node result, which means then when I call upon showTree for the very first time, I send to it, well, in this case it would be a depth number, probably 0, and also a reference node variable that had been set up. So what does this actually look like? Here's our variable sitting outside called result. And everybody would more or less get a result. So these are all results. But these results that I'm drawing, they are the result that I just drew over on the right-hand side. So anything that goes into any of these boxes, whatever is put into them, is the same thing as putting it directly in here. So once we finally get done with the entire recursive loop and we exit out, we can simply work on result. So if anything was found, so let's go ahead and shift gears from thinking of showTree to FindNode. If anything was found inside the hierarchy, when we got done walking through the hierarchy, back out here, the result would contain the node we were looking for. If nothing was found, we could set it up such that result is simply null. So if we started off with null, walk through the tree, or walk through the hierarchy, get back out. If it's still null, we didn't find anything. If there's something in there, though, then we did indeed find it. So that is what we're going for here. Make sense, Logan?
Right. It's like taking the result is like putting a mouse trap into a barn filled with mice, and then you leave. All the mice run around and possibly get caught in it. Then you come back and look at the mouse trap and see if there's a mouse in it.
I love it. So once again, all of these guys are directly touching this guy, since we are passing the variable by reference. So it's passing the parameter by reference. Okay? So with that being the case, Logan, let's go ahead and jump back over into Visual Studio, and let's find our FindNode method.
Scroll up a little bit. And here we have FindNode.
Okay.
And we have apparently the one with only with no recursion, or no, excuse me, result.
Ah, so here's the deal, because obviously we want to keep this, we want to keep this as simple as possible on the outside world. Meaning on the outside world, I don't want to have to pass a variable by reference or a parameter by reference. So we want to be able to just call upon a public FindNode method and give it a name. So what FindNode method's going to end up needing to do is turn around and call FindNode method, but a FindNode method that is overloaded to take in two parameters, that name and a reference node.
Okay, let's set up that method. Let's put together a public void FindNode that takes in, and let me correct my casing real quick. So we have a FindNode that takes in a string name, again, and also takes in a result node by reference. So it's ref node result.
Okay, and before we get much further, let's go ahead and jump back up to our public one, and let's show them setting up that local variable, and then setting it to null, and then passing that into FindNode, and then returning it.
So setting the mousetrap, sending it into the mice, and then looking at it.
You got it.
So this variable is going to be called result. So we'll set up a node called result, and we'll initialize it, or set it to null, so that way the local variable is assigned.
Okay.
Then we'll turn around and we'll run FindNode, and we'll pass it the name, and we'll also pass it the
result by reference.
So yeah, we'll pass it ref result, and then we'll turn around and return whatever happened to be in result, even if it was still null. So we'll return result.
Okay, but change result to return.
Score 1 for spelling. So return.
Yeah, you just simply hit enter is all it was.
I got you.
Okay, so check this out. How cool is this? So we have a find node that is exposed to the outside world because it's public, and it simply returns a node. It's that easy. And it takes in a string name. So we're looking for a node by this name. Because when we get the architecture completely nailed down, you will never be able to have two nodes with the same name, because we're going to put name validation in real soon. All right, so we simply call upon this from the outside world, and we give it the name that we're looking for. Now, internally, what do? We create a local variable called result that will hold any kind of node. It can be a transform node, it can be a shape node, geometry node, light node, whatever. It holds a node. We start out by just setting it to null. Okay, then we turn around and we call upon our private or internal, so we're going to need to go ahead. Let's do that real quick. Let's make this private. The outside world does not need access to this because this is a little bit more sophisticated, and I sure don't want to rely on them doing this using the reference passing. All right, so what's going to happen is we're going to call upon our own private find node, and we're going to pass the name that came in, so our name parameter, and we're going to pass by reference the result variable. Okay, meaning that inside a find node, if we put a found node into result, this result is being populated with it. So this result suddenly contains the information we need. Check this out. Now we simply return that result. So if a node was found, it gets returned. If it doesn't get found, that's fine. The null gets returned. So it really does work out great for us. All right, so let's go ahead and jump down into the find node, the private one, and let's start coding this in.
Okay. Now, if we're running find node, the first thing we want to check is see if we are the desired node.
Sure.
So we can do a check and say that if this dot name is equal to the name parameter, well, then the node we're looking for is us. So we can put a reference of ourselves into result. So we can say result equals this. Now, if this node that we're looking at that we ran FindNode on was not the correct name, then we need to pass that result down to all of our children and see if any of those are the desired node, and then they will in turn do the same, and so on.
And this is the exact same thing that we demonstrated with show tree, but instead of passing and incrementing depth, what we're doing instead is simply continuing to pass the name that was sent in that we're looking for, along with this reference node result. So from any of the recursive spots, as we work our way down deeper and deeper through the hierarchy, at any point we find it, we simply populate result. And that result in the outside world is going to get it.
Okay. So let's code this in as an else. So if we didn't find a result, let's run a for each. So for each TransformNode child in children. So again, just like in showTree.
Mm-hmm.
And then for each of those, we want to call upon each child's FindNode, where we pass in name, the same name parameter that was passed to us, and the same result reference. So reference result. And so that will pass it on down the chain where that one can do the check and set result or continue to its children and so on and so on.
So we have the exact behavior that we had over in showTree, as we are now able to simply walk all the way through a branch of a hierarchy with all of the children and their children and their children. And at any point in time, if we simply stumble on the name, that name gets popped over into result, which through referencing, we have access to all the way back into the initiator of this particular FindNode method, which is all the way back out right here. So it's really cool because FindNode back out here there's not an equals on the left-hand side, then something over here for us to put a result in. It's just when we come out of it, it's sitting right there. If anything was found, it's right there. So we can simply return it. All right, very cool. So, well, that was simple. That's all there is to it. All right, what do you want to do next, Logan?
We could play around with it, test out the FindNode functionality. So first, let me build. And okay, good. Everything has succeeded. Now let's play around with this in program. Let's set up a variable so we can play around with a possibly found node. So I'm going to make a TransformNode variable called FoundNode. Let's say that FoundNode is equal to, let's pick on A, node A. Let's hold node A to find a node by the name of B.
Okay.
So if a node B was found, node B should be stored in FoundNode.
So basically what you're saying here is, by the very nature of how FindNode has been established, meaning it's an instanced method, we have to call upon it from a particular instance of TransformNode.
Right.
So from somewhere within the hierarchy already.
Right.
So in this case, you started it all the way up at the root. Well, actually, no, you started it at one root, at node A's. But we're not going to walk through all the other hierarchies.
And the problem with this is if another root contained a node B, we wouldn't find it.
That's right. So let's go, which it's not going to, because it's going to be in a group.
So let me do a check, though, so we can see what the result was. I'm going to do an if on that found node, because I want to check and see if we had actually found something. So if found node does not equal null, so if we actually found a node, then let's write out that we found a node.
Okay.
So I'll write out saying that found node, and then add on to that whatever was in
found node. Okay.
Now, I'll put in else, so otherwise, we didn't find anything. So I could just do a console write line saying...
node not found.
Yeah, node, I like that. Node not found.
So you got found node not found.
Great. And how about that?
Not.
Node, wait, no, begins with node. Wow. Don't try to mince lines when it's really, really late. Node not found. I'll just retype it line character by character backwards. How's that?
There you go. Perfect. Yeah, it is like 5:52 in the morning, so yeah, it's been a late night. Okay, so beautiful. Let's go ahead and see what we get. And we have an error.
The error was node A.findNode. Ah, I see. It's returning a node which we can't safely we can't implicitly cast a transform node. To correct this, because if we go back and actually look at FindNode, we're returning a generic node. So if I change this to node for FoundNode, because we're doing simple things like just showing its name, we don't need any of the transform properties. So I'm just going to change our variable to be of type node.
Okay.
So now if we run, we can see node not found. Why? Let's look at A. Does A have a child B?
No.
No, it doesn't. B was under group.
So let's simply change it from looking at node A to looking at group.
So if we look for node B under group,
well, actually, it's still gonna be. You're still looking for B. What's changing is.
Oh yeah, we're still looking for.
It's who you're calling. That's right. Which I don't know if we actually have a reference to group.
We'd have to look up for that first, but before we even did that, we'd have to look up, or we'd have to have something that would find all roots.
That's right. So, excellent. We've already worked ourselves into a corner quite quickly. So what we need to do now is go ahead and set it up so that we can walk through and check every single node for a particular node.
All right. Let's jump back to TransformNode, and let's address the static find method.
Okay.
static find is similar to the static show all, where we want to find everything no matter which root node it was a descendant of. That means we're going to need to begin by looping through all of our root nodes.
That's right.
So let's start with a for each. So we can say for each TransformNode node in
root nodes.
Root nodes. So for each node, let me bracket this in as well. So we want to say that we have a node result that is equal to the current root node that we're looking at in node dot find node, and then we'll give it the name that we're looking for. So we'll simply pass it the name parameter.
Okay.
Then
what we do is just turn around and check to see with each time we walk through this, was it found in that particular root node branch? Yeah, root node branch.
If it was found, there's no reason to search any farther.
That's right.
So let's do a check and see if the result was not null. If it was, we can return, and there we go with return and result again. So we can return the result, and we can, as a matter of fact, let me make this one step more efficient. Let me bracket this in as well. So if we return, oh no, excuse me, I was thinking of something else.
Yeah, so basically all we need to do is return the result, and that's going to jump us out of the for each loop.
Exactly.
And so that wraps it all up. Otherwise, at the very end of the for each loop afterwards, we just need to return null because we never managed to find the node we were looking for in any of the hierarchies. Okay? So now you have full control, Logan. Now you can go look for group B.
All right. So instead of telling node A to look for it, instead we could say something like transform. Let's see, why is it not wanting to give me transform node? Let me build and make sure that there's no errors introduced. I don't see any here. So node find node equals transform node dot
and then find,
and let's pass it group.
Okay. Okay, and it found group.
Very nice. So now we could go back to what we were trying to do originally and find B.
That's right.
So despite the fact that we need to search for a group being a root nodes are searched for now. And we found node B because B was found under the group.
And now try to type out something that's not in there, like BB. And node not found. So now we have a way of walking through all of our nodes, looking for a particular node, and once we have a reference to that particular node, we now have access to its parent. We also have access to all of its children. So from there, we can do all sorts of neat things. Is there anything you want to add to this, Logan?
Nothing I can think of.
Okay. Well, that is going to wrap it up. Like I said, as far as the private find node goes, it works very much like the show tree. It's just recursive in nature, and it continues to call upon each of the child's nodes, so each child within that particular instance of TransformNode's children list, and it keeps calling upon each child's find node, and it continues to pass the name that we're looking for and the referenced result, so that if the result is found at any point, we simply populate that result, and then we have access to it once we get done with all of the recursion. So with that, that is going to wrap up this video. Thanks a lot.